The first angel blew his trumpet, and there followed hail and fire mixed with blood, and these were thrown upon the earth. And a third of the earth was burned up, and a third of the trees were burned up, and all green grass was burned up.
As the massive CME gas cloud travels through space, it can take anywhere between 12 hours and several days before we feel its impact on Earth. On hand to capture its passing is the SOHO satellite, with a sensitive instrument called a coronagraph on board.
The SOHO satellite has telescopes monitoring the outer atmosphere of the sun. SOHO sees CMEs lifting off from the surface of the sun, headed towards the Earth.
But there's a problem. There is no way of knowing how fast the CME is traveling.
We can't track them between the sun and the Earth. We're only guessing. We're only hoping that it won't be as bad as it could be.
So what would a power station guy say about today's activities?
It could get a lot worse if the information from NOAA and the satellite sticks.
How much worse?
Well, look, some CMEs usually bounce off the magnetosphere, right? But not all of them do. If they're big enough, they can get through. One day we're going to get hit by beauty, and when we do, it's going to knock out the entire electrical system.
Are you saying that all of New York could be blacked out?
Not just New York, every major city on Earth. It's going to last for weeks, months, years. No electricity, imagine that? It'd be like winding the clocks back hundreds of years.
This ultimate solar storm won't hit all at once. It will strike in stages. The first part of the storm, the solar flare, is moving way ahead of the CME. It takes just 8 minutes to get here. Commercial airliners are now in extreme danger, as X-rays within the flare can wipe out radio communications on any plane flying in its path. Following quickly afterwards, just 8 minutes behind the solar flare, is stage 2. This is called the radiation storm. This will cause more serious problems.
This is real radiation. These do radiation damage. They stream into the upper atmosphere. Electronics can be fried by these high-energy protons.
Down on the ground, we're shielded from the worst of the radiation storm by the combined forces of the magnetosphere and atmosphere. But anyone caught outside this defensive barrier, like astronauts, has only a few minutes to get to safety, or they will get hit with a high dose of radiation. Traveling at 2,000 miles per second, the final stage of the perfect solar storm is the massive billion-ton electrified gas cloud, the CME.
CMEs blasting out from the sun carry the solar magnetic field with them. They're a supersonic solar hammer streaming through space, which then impacts the outer regions of the Earth's magnetic field.
But the CME's impact is highly unpredictable, and for emergency managers, a deadly variable.
Take a look at this. It's the latest information from satellite.
One for station supervisor.
Whoa, whoa, whoa. The CME left the sun at the highest speeds I've ever seen. And the solar flare that came before that was huge.
Could it affect the grid?
Who knows? Nobody's ever seen anything like this before. You know what? This could be it.
What?
It could be global.
This is powerful. Oh, it's coming at us real fast. My best guess is it's going to hit us in less than 12 hours.
The Earth has now been hit by the first 2 stages of the storm, and the plane heading to New York is in real jeopardy. The solar flare has knocked out its communications, and the solar radiation has damaged the electronics, causing 2 of the engines to fail. The solar radiation is also now beginning to have an effect down on the ground. Global positioning satellites have revolutionized navigation, but they will become one of the many casualties of the solar storms overloading electrical circuits and bending signals. If you're in a car and dependent on satellite navigation, this will be inconvenient. But for pilots trying to land a passenger jet in low visibility, the accuracy of this technology is critical. Now only a few minutes away from New York, the plane's navigation system and 2 engines are still not working.
So what's the plan here? Do we have a strategy in place or not?
There's a sad truth here, which is that we're never going to be fully prepared for any kind of major catastrophic event. So what we want to do is get to a point where we would be able to protect as many people as possible. But I don't think we want to make anybody feel that the expectation is perfection, because we won't be able to get there.
Hello? Madam Mayor, if the transformers are damaged, we're going to be out of power for a lot longer than a few days.
It takes months to replace them, even years.
What do you suggest we do about this?
Yeah, there is something we can do, but you're not going to like it.
City emergency managers are trained for most eventualities, but this one will test them to the limit.
Well, Mr. Wright, I strongly suggest that you get over here so we can discuss this fully in person. Thank you.
One of the most accurate sources of information that will be available to the mayor will come from the ACE satellite. Launched back in 1997 by NASA, ACE, now positioned directly between the Earth and the Sun, is designed to predict just how powerful a solar storm can be.
The ACE satellite monitors the various parameters of the solar wind: magnetic field strength, magnetic orientation. These are essential for predicting the strength of the impact of any solar event on Earth.